All right. Good morning and welcome to this video on the topic of current electricity. I will clarify a lot of doubts. I have seen a lot of students struggling with questions, where you have to find the current in each branch. You can see this, right? Current in each branch. So this is where a lot of students struggle. So if you see this question, this is a branch. 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 So what we are doing is we are solving, right? Electrical circuit or electric circuits, right? There is a source of battery from where the current comes, and then we are expected to find the current or potential difference across branches. So AB is a branch. I hope this is making sense. AB is a branch. Okay. What is this whole diagram? What is this whole diagram? This whole diagram is a circuit, right, in which the current flows. So you must know this is also an arm, right? If you just want to understand the basics, I will solve this now. So let's start understanding what this is all about. All right, so the current comes in like this, okay, and at this point, at A, the current splits as per Kirchhoff's current law, right? So first rule you must know to solve electric circuit is Kirchhoff's current law, and then the second law which is used is the Kirchhoff's voltage law. This is also used, right? And Kirchhoff's voltage law is to be applied in closed loops. Okay, closed loops. Okay, so if you don't know what is Kirchhoff's current law, what is Kirchhoff's voltage law, and third rule that you need to learn is the Ohm's law. Ohm's law. These three, together, if you know these, you can solve any electrical circuit. So these are used to solve any electrical circuit. So when I say a closed loop, for example, this is a loop. Let me show you the loop. A loop starts from A, right? And then you go like this, and then you go like this, it ends at A. This is called a closed loop, right? So even if you look at this, you start from A, go like this. This is a technique being used by the student to solve the circuit, right? So to solve the circuit, you need some techniques, right? These are the techniques or the rules utilized. And of course, there are rules that you need to follow. You need to select the loops, right? So this is also a loop. It starts from B, B, C. You can name this also. If there is no name with this, maybe you can call it D. So B, C, D, B, right, is a loop. The loop starts from a point, ends at the same point. I hope this is making sense. So you will get a lot of questions in which you always are asked to calculate the current in each branch or the potential difference. Maybe they ask you to calculate potential difference between A and C, right? A and C. So this is the potential difference between A and C, right? Even to find potential difference across 2 points in a circuit, you need to know these three techniques. And just emphasizing that if you are not using these three techniques, KCL, KVL, and Ohm's law, then you will not be able to solve these questions. So always ensure while solving these questions that the three rules are clear in your mind. If you have not understood these rules, go to my YouTube channel, search for the playlist Current Electricity, and watch all my videos on Kirchhoff's law and Ohm's law. All right, now let's try and solve this question, and I will just remove these what I've written, and then we will solve this, okay? Because we are doing it on real-time basis. All right, so I will just remove this, and we will then solve this. All right, let's first go to the fundamental, which is the circuit itself, right? So you have to find the current. I will just enlarge the certificate, you can see the circuit now, right? This is a circuit, and we have to create equations. All right. So let's say, we start with the battery, and I'm doing this slowly, deliberately, so that you take your own time to understand this. Some of you may know this, but you can still watch how to do this. Okay. The first step number one is, start from the battery, decide the current in the battery always as I1. The current enters A, right? So some potential is lost here, right? So battery has a potential, some potential is lost across 10. The balance potential appears across the balance circuit. So this is what I mean. If you have this 10 volt, this is your 10 ohm resistance, and then you have the balance circuit, right, between A and C. So for example, between A and C, the effective resistance between A and C, the effective resistance is some value RAC, right? So essentially, if you see, out of 10 volts, some potential will be lost here, and the balance potential then appears across AC. I have drawn a single effective resistance against AC just to tell you in a simplified manner. Obviously, finding RAC is not easy because this circuit is very complicated. Now, this is an important point to note. Don't get tempted to apply Wheatstone bridge on this particular circuit because the ratio is 2 is to 1, which is 10 by 5 is to 1 is to 2. For a Wheatstone, the ratio on right hand side also should have been 2 is to 1, which it is not. It is 2 is to 1. And on the right hand side, it is 1 is to 2. So you cannot apply Wheatstone bridge on this. Be very careful of this, right? So since we cannot do a simplified RAC is not possible, we cannot use parallel or series. We will have to apply the rules I told you, which is KCL, KVL, and of course the Ohm's law, which is very popular, right? So we will use these three and solve these, numerical. All right. So let me just rub this also off and go back to the circuit. Circuit is where you need to pay your attention to. Okay. All right. So I hope this made sense that it is not easy to solve AC, using an effective resistance technique or parallel and series, and therefore now the complicated circuits get only solved using KCL and KVL. So the current enters here, the I1 current enters here. Say the current splits here, it becomes I2 and I3, right? I2 and I3. So at this point A, I can write the first equation, which is I1 is equal to I2 plus I3. So the current entering a node is equal to the current leaving the node. So this is your Kirchhoff's current law. This is the first thing. And then I2 enters here. Then this is I4 and this is I5. At B, if you see B, right, AB branch, I2 is equal to I4 plus I5. So this is also Kirchhoff's current law. Now so we have got two equations, right? And we were supposed to find the current. And of course, this is I3. Now let's name this as D. So I3 is coming here. Here it is I3 and I5 is coming here. So two currents are entering D. So the outgoing current will also be known to us as I3 plus I5, right? So let's talk about C now. If you talk about C, I4 is entering, I3 plus I5 is entering. Two currents are entering at C. So what is the outgoing current? Outgoing current is going to be I3 plus, okay, so you have I3 plus I5 plus I4, right? This is the current which is incoming for C, right? So, and what is outgoing current? It is equal to I1, right? So one more equation. You can see at C1, this current is entering, then these two are entering, and the outgoing current is I1. So I3 plus I4 plus I5 is equal to I1. This is one more Kirchhoff's current law, right? So you could apply you applied Kirchhoff's current law 3. And I'm again going very slow with the question, and so that you can understand it. I can solve this in 4 or 5 lines, but you will not learn anything out of that. All right. So we have already used Kirchhoff's current law quite a lot, right? So we applied Kirchhoff's current law at this point, then we applied Kirchhoff's current law here, and then of course, to calculate I3 plus I5, we applied it here to apply, and we also applied. So almost at every node where there are 3 branches meeting, you can see, how many branches are meeting at A, this, and this, 3 branches. At B, this. So 3 branches are meeting a node. We applied Kirchhoff's current law, right? So more than 2 nodes, generally you would apply it. All right. So Kirchhoff's current law gave you three equations, right? So I hope these are making sense to you. I'll just enlarge it so that you can take a look at the equations clearly, right? So I told you, while you're solving these questions, you should also be aware that, have I used Kirchhoff's voltage law so far? So Kirchhoff's current law, straightforward, you applied it, but have you used Kirchhoff's voltage law? You have not, right? So in my mind, the logic is I have to use a Kirchhoff's voltage law also. So my concentration now is to apply the Kirchhoff's voltage law. Okay. Now, Kirchhoff's voltage law is applied on loops. So let's first select the loops. And my first preference when I'm solving the questions is to always have a loop which has a battery. Okay, so this loop, if you see, I will use a color which is different so that it's easy for you to understand. Is I will use this loop first. Okay, this is the loop I would like to use because it includes what? It includes the battery. Okay, so my thumb rule in my mind is that always, while applying Kirchhoff's voltage law, have one loop which has the battery. Now what do? The Kirchhoff's voltage law says that the sum of increase in voltage when you traverse a loop is equal to the sum of voltage drops, right? So if I move in this direction, the minus to plus, 10 volt gain is there. So 10 volt gain is there. And when I move in this direction and I apply Ohm's law here, right? We also said we have to apply Ohm's law. So the potential drop across this is 10 into I1. It's a drop. Remember, the direction is, current direction. So it's a drop, right? You're moving from higher. This is higher potential point. This is a lower potential point. The current can only move. So it's a drop. So this is a gain. And on the right hand side, I am writing the drops. So 10 I1, 10 into I1, right? V is equal to IR. I have applied. Let's move here. Again, you can see there is a drop because the current is flowing in I3 and the loop direction is also the same. So the current direction and the loop direction are common. It's a drop. So let's write this plus 5I3. Let's move forward to the next one, which is this one. What is the current in this? I3 plus I5. So 10 into I3 plus I5. So 10 is equal to 10 I1 plus 5 I3 plus 10 I3 plus 10 I5, right? I hope this is making sense. All right. So this is 10 is equal to 10 I1 plus 15 I3 plus 10 I5. You can see the number of currents we are supposed to find, is so many. Every branch has a different current. Right from I1 to I5, at least we have to find 5 currents at least, right? We have created 3 equations and the 4th equation also, right? You can take note of this, that so many currents have to be found out. So first, KVL has given you an equation of 3 currents. You can see this, right? 10 I1, 15 I3, right? So this is 15 I3. I'll just make it more clear. So this is one. Now, see, I'm trying to solve this in a very limited space so that the visibility of circuit is in front of you. I would recommend that when you solve this question, always keep the circuit in front of you. It's easy. Generally I would solve in this manner so that the space is available to us. So I'll just shift it towards the left, so that more space is available. So, and then of course, let me just write this as equation number 1, equation number 2, equation number 3, and equation number 4, right? So let's say we have applied KVL once. Let's select one more loop. I would like to select this loop now. Okay, this loop, you don't have a choice. It cannot have a battery, right? The loop I've selected now is the loop A B D A, right? And again, I'm applying KVL because I know KVL has to be used. So let's say A, B, D, A, if I apply, what does it give me? If I'm moving in the direction, so this is I2, 10 into I2. This is a drop. It's a drop. Then I enter BD, which is this. The direction of loop and the current is same. So plus it is 5 into I2. Sorry, it is I5, right? So let's write I5 and then let's move. Now, if you see this, the loop is the clockwise loop, right? So this particular arm is what I'm referring to. The current in this arm AD. So if you see the arm AD, the current is like this. So this is your current AD. And loop is in this direction. Loop is in this direction, right? So loop and current are reverse of each other. So we will not apply a positive sign but a negative sign. Just note this, the sign convention of Kirchhoff's voltage law. We are moving in a loop. The direction of loop and the current in the branch are in the same direction in BD. So see BD, right? I will just draw BD. And I'm doing it for students who don't know how to apply this, so that you learn how to apply Kirchhoff's voltage law. So, right, I'm just drawing BD. So this is your BD, BD. The loop is going in this direction, right? And the current is also going in the same direction. So you can see I've used what sign? I've used positive, positive, right? And then the drop side on AD. AD is a drop, potential drop. So KVL states that the sum of drops is equal to sum of gains, right? So although this sounds like a drop, actual drops are these, right? So if you refer to the arm BD, it's a drop. If you refer to the arm AB, it's a drop. But in the arm AD, it's not a drop, it's a gain actually, right? Because as per the sign convention, although potential always drops, but as per the sign convention, we will treat it as a gain because of the opposite direction of the loop and the current. So current is, going in this particular direction, which is I3, and the loop is moving in the opposite direction. So I will write this as 5 into I3, right? So one more equation created out of the loop ABDA, right? So this is equation number 5, right? Let's talk about the next one, which is the equation number. So let me just select one more loop, which is this one, this loop. Okay, let me select this loop, which is B C D B. Okay, B C D B. Let's move in BC. In BC, you can see the direction of loop and the current is same. So plus 5I4. I'm using drops on the left hand side. So these are the drops. These are the drops. This is a gain. So drops and gains have to be equal, which is what I'm doing. And 5I4 is this is what I've covered now. Let's move here. Here you can see the direction of loop is clockwise, but the current is moving in the opposite direction. This is the direction of the current. So I will write this on the right hand side as 10 I3 plus I5, treating it as a gain. And then of course I will go to the next one, which is the arm BD, DB rather, right? In DB, the loop is going upwards and the current is going downwards. So this also will be treated as a gain. And I will write this as plus 5 into I5. So you can see the current in BD is known to you. So one more equation found. Right now, the point I'm trying to make is start with as a beginner and try to create as many equations as possible. You will see some of the equations being duplicated and not required, right? So we know there are 5 variables. We have to find variables, which is I1, I2, I3, I4, I5, the current in each branch. And the number of equations should also be the same. The number of equations which we need to create is 5. Whereas what we have done so far is we have created 5 equations. I'm just creating one extra one, which is this one, right? So I have 6 equations with me now. Let me just write them together and then decide, which equations are easy to solve or make more sense to me, right? So if I simplify this one, fourth one, and take 5 as common, right? So if I divide this whole equation by, divide by 5 or take 5 common, I will get, all right, so this is what you get. You get 2, right? I'm just simplifying 4. So you get 2 is equal to 2I1 plus 3I3 plus 2I5. So this is the simplified version of 4. Let's pick up this equation also, which is the equation number 5. Take 2 common again. So you get 2I2 plus I5 is equal to I3. And let's pick up equation number 6 and solve it. So if you pick up equation number 6, which we built from BCDB, right? BCDB. This is the loop we had used. So this is I4, right? This is I4, 5 is common, is equal to 2I3 plus 2I5 plus I5. So I4 is equal to 2I3 plus 3I5. This is equation number 6, right? So we have equation number 1, 2, 3, 1, 2, 3, 4, 5, 6. See, another thing you need to understand, and when you're solving these questions, and I'm solving as if a student is solving. I'm not solving as a professional who knows what is to be done. I'm solving and thinking the way a student would think, right? Any student, who's a beginner would start the way I have done this whole thing, right? So we have landed up with a situation where we've got 6 equations and 5 variables, okay? And this is one of the confusing points for students. See, generally when you solve these questions, you're unsure as to what loops or what nodes you have to consider, right? And therefore you land up with 5 equations and 5 variable kind of situation. Our aim is that we should have, if we have 5 variables, we should have 5 equations and 5 variables. 5 equations and 5 variables. This should be our aim actually, right? This is what we need to target, right? Which means we will have to eliminate one equation from them. If you look into this equation very carefully, the equation number 1 and 2, right? If you look into 1 and 2, and if you add 1 and 2, if you add 1 and 2, 1 plus 2, you will get this. I1 plus I2 is equal to I2 plus I3 plus I4 plus I5, right? So what will happen? Your I2 will go away. You will be left with I1 is equal to I3 plus I4 plus I5, which is identical to 3. So actually 3 is redundant, and that is why I use the word redundant here, right? Because 1 and 2 together are capable of giving you an answer which is 3. If you add 1 and 2, you get 3. So 3 is not required, right? So generally when you apply Kirchhoff's current law, this is another kind of back test you need to do, that your number of equations and number of variables are not equal. How will you bring them to equality? By looking at KCL. And sometimes you overdo KCL, right? I overdid KCL. I applied KCL very blindly. A good strategy would be that you first depend on KVL. So if you want to solve the problem, depend more on KVL and then you apply KCL, right? This could be more beneficial. But Everybody has their own way of solving. I just wanted to tell you, a beginner level student, how will they solve this? Now you have five equations and five variables. What did I do in this step? What I did in this step was, you have to reduce the number of equations. Reduce equations, right, is another important step you need to take. And now you have five equations and five variables, because three is redundant. You have done one more step. You have reduced the you have made the number of equations equal to number of variables. But generally, in a question, you have to reduce the equations. And when you will solve the question, this is what you will do through process of elimination. And it is a bit tedious to have five variables and five equations. It is a long process of elimination. And finally, you will find I1, I2, I3, I4, I5. There is no escape. You have to do that. So the next step generally people do is they reduce the number of variables, right? Sometimes people also have too many variables in the question, the answer they're trying to build, the solution they're trying to build. Also try to reduce the number of variables. Don't have frivolous, variables. For example, here, let's look at I3 plus I5. I did not take I6. Don't do this. If you can get a current in this branch by KCL, which is sum of this current and this current, which is entering this, don't introduce I6. Do not increase the variables. Keep your equations as low as possible. Obviously, equations and variables have to be equal. You don't have a choice there. But try to reduce the equations finally, which I did. I made this redundant. Also, then work on reducing the variables. And then finally, solve the five equation, five variable, or three equation, three variable, whatever is the question, and get your respective answer. So I1 is a branch current, I2 is a branch current, I3 is a branch current. You can solve this and find this. I know it's a bit tedious to do that part, but you should be learning how to solve those equations also. It's a bit of algebra and process of elimination. So I hope this numerical gave you an important insight into how to apply the KCL and KVL. If you're a beginner, this is the way you need to do. Take care of polarities, what the current direction is and the loop direction is. Just for your knowledge, if I were to give you another example, let me draw another circuit, okay, and again give you some practice on applying a KVL. So this is your voltage, right, and this is your, for example, I'm making something which is obvious, but to make you understand, this is your, for example, a circuit, right? The Always include the battery first, right? So if I don't use parallel and series circuit, right? This is, for example, R1 and R2. These two are in parallel, right? I can straight away solve this, but let me show you how to apply KVL in this. Always select a loop which has battery, okay? Always select a loop which has battery included. So loop having a battery makes a lot of sense. Having a battery. This will simplify your life, okay? If you have another circuit, so I will select a loop like this. Let me just use a color here, right? I will select and typically what I do is, whatever is the direction of current, I select the loop, and I call this an outer loop, right? This is an outer loop. The periphery, the boundary, right? This is a boundary. So I always select a boundary loop. Always select a boundary loop. That really helps, It really helps cover a lot of elements. What do I mean by elements? So this got included, this got included, this also got included. Maybe there was another resistance here, even that would have got included. So having a boundary loop makes sense. Then, you can have another loop, which is your left loop. So this is your left loop, right? And this is your right loop, right? So have the concepts built in your mind. Left loop, right loop, a boundary loop. Apply Kirchhoff's voltage law very intelligently. So I was telling you how to apply the Kirchhoff's voltage law. Assume I took this sign convention and the direction of the loop is this. And then what I have to do? First, I have to apply. So the current goes, the current splits here. It splits here. It comes back. So these two currents are coming here. They're joining. So this is your I1. When it splits here, this is I2, this is I3, and this I3 is coming here, I2 and I3, and this is again I2 plus I3. So your I1 is equal to I2 plus I3. You can see the incoming current is same as outgoing current, which is I1. Now, this is KCL, right? But I was telling you, so let's look at the external or the boundary loop, right? The external loop. So battery is included. I will move along the loop. Okay. When I move along the loop, I'm moving like this. So first I get a negative terminal, then I get a positive, which is a gain. So let me write the gains on the left. Okay, gains on the left. So gain of V voltage, which is battery voltage. Let me move with the loop. See the current direction here and the loop direction is common. Say this resistance is R3. So this is a drop, right? From positive to negative. The current always moves from positive to negative. So therefore it's a drop and the loop direction also is in the same direction. Both have to be considered. If they're in the same direction, the drop, I will write the drop as a positive drop on the right hand side. This is a gain. I am writing drop. A drop is positive if the loop direction and the current direction is common. So this is R3 I R3, right? And Ohm's law. And let's look at this, right? This is also a drop. Current moves from positive to negative. The loop direction and current direction is same. So therefore it is R1 into I3. Let's look into this particular one, right? If you, this is R2, right? So the loop is in the, so R2 is not included in this. R2 is in the left loop. So I hope this particular KVL, the loop, which we considered the external loop, this is clear to you. Let's talk about the left loop, which is this one, left loop. So if you look into the left loop, I am just going to concentrate first on R2, which is this. If you look at R2, the loop is going upwards, right? The loop is going upwards. The current is coming downward. Now, definitely current is coming downward from plus to minus, but the loop is in opposite direction. So current is going like this. The loop is going like this. You may be tempted to write, this as a positive sign. Don't. Write it on the right hand side itself, which is the drops, but this is a negative drop or a gain. So write it as minus R2 into I2, right? There is no battery in this. So zero left on left hand side, it is zero. If you look into this, this is a drop, right? But the loop direction is same as the current direction. I'm referring to this and I'm referring to this as part of the left loop. So this is your left loop, right? So on the left loop, you can see R3, I3, will be plus because the loop direction and current direction are common. And then of course you have R1 and this one, R3, R1 and I3, right? So there is no gain here, right? So I have written zero. There is no potential source available in the left loop. So I hope the sign convention of loop and the current direction, you're clear on them. This is very important for you to understand how you use this. This is the crux. A lot of students do mistake, and therefore I did this small practice with you. So you have to go through this video multiple number of times, listen to every sentence very carefully, make your notes from this video, important steps that you see, practice on your own, and then you will see finally you will understand how to solve complex electrical circuits using these new techniques. In class 10th, you learned about Ohm's law. In this, you learned about KVL and KCL. These are mathematical techniques based on physics principle, help you to solve complex electrical circuits. No channel, no application, no website in the country will give you the explanation of a solution. I could have solved this question and just written it down, but you would not learn anything because the explanation is missing. And what good is a portal or a website or app if there is no explanation available? The more detail is available, better is your learning. So my job as a teacher is to help you understand, which is only possible if I explain. Written down answers on a portal or a website don't talk to you. They don't give you why they have done what. They don't give you a practice, which is very important for you to build your own logic. So listen to my videos, subscribe to my channel. Do not miss out on important videos that are coming on this topic. So I will spend some time on this topic so that you build good concepts in this area. Also, don't forget to watch my videos on potentiometer. Fantastic numericals done on potentiometer that will help you a lot in solving the potentiometer. Excellent explanation available. Thank you very much for your time today, and I will come to meet you tomorrow with a numerical or maybe a topic. If you want a topic to be covered, you can type in your comment section if you want some topic to be covered. I will cover that. Otherwise, I will decide the topic and put the numerical of my own choice. Thank you very much.